Let's start chapter 6.1, which is called U substitution, and we'll find out why in a little while. The first question should be, why should we care about chapter 6.1? My answer is because not every sine and cosine wave have a frequency of 1, right? So we can integrate cosine of x at this point, but we don't know how to integrate cosine of 3x yet. We can integrate e to the t, but not everything is exponential growth. A lot of things are exponential decay, but we don't even know how to integrate that yet. And exponential decay is really important. So the name of the technique we're going to learn that can do both of those things and others is called U substitution, and it's basically the opposite of the chain rule from derivatives. This is a big section, and I've divided the homework into 2 parts. And in the big homework file it says, here's part 1, and that's all about indefinite integrals in U substitution, so with no starting and stopping point. Homework part 2 is about definite integrals and maybe a little bit of review of indefinite integrals. So let's start with this, just plain old sine wave with a frequency of 3. What would you say f prime is? Well, derivative of sine is cosine, right? And then we have to multiply by 3x prime for the chain rule. And then you'd say, well, that's derivative of 3x is just 3, or you could write it as 3 cosine 3x. Okay, so far? So an antiderivative of cosine 3x times 3 is what? Well, we just took the derivative, so to take the antiderivative, just look backwards, and you'd say just sine 3x, right? I just said an antiderivative, so you don't need the plus c. That would be the general antiderivative. So what if I didn't have the plus? What if I didn't have the times 3 there, like my example here? What can we say about that? So antiderivative of cosine 3x is, any guesses? Well, one way to think of it is 1/3 sine 3x. You could say, well, the new function I have here is 1/3 as big as the old function, and so my new answer should be 1/3 as big as the old answer, kind of using the constant vertical multiplier rule and a sense of proportionality. That's a good way to try it. But it's also good to check our guesses, right? So we could say, what's 1/3 sine 3x? What's the derivative of that? Do I need the product rule? Nope, it's a constant vertical multiplier. So I can just copy the 1/3 and say it's not sine anymore, it's cosine 3x times 3x prime, which gives me 1/3 cosine 3x times 3, which is cosine 3x, which matches what we started with. All right, so let's handle some kind of exponential growth stuff. We'll get to exponential decay later, but let's just remind ourselves, if f of x equals e to the 5x, then what is f prime? Hopefully you said e to the 5x times 5x prime, which is e to the 5x times 5. I know some people have difficulty kind of spotting the inside function like we always do with chain rule stuff. It might help to rewrite e to the 5x as exp 5x, because then there's something in parentheses which maybe makes it a little more obvious as what the inside function is. Let me show that those are the same, and then we got the derivative there. So an antiderivative of e to the 5x times 5 is, what would you say? Well, we got it there, so, and that was the derivative of that, so that would just be e to the 5x, right? An antiderivative of e to the 5x without the times 5 is what? Same logic as before, we would hope. 1 over 5 e to the 5x. And then you would check it by taking the derivative. 1 over 5 e to the 5x prime. 1 over 5. Derivative of e to the stuff is e to the stuff times derivative of the stuff. And that all boils down to e to the 5x. So far, we're looking good, right? Let's try another one. How about f of x equals e to the x squared, which you could also write as exp x squared like that. What is the derivative? You'd say derivative of e to the stuff is e to the stuff times the derivative of the stuff, which would be e to the x squared times 2x. Okay, so far. And then, if I ask the same question I've been asking, what is an antiderivative of e to the x squared times 2x? Another way of saying that is, so you could also write that as what's integral of e to the x squared times 2x dx. Well, we know that the antiderivative of that is that. Seems pretty good so far, right? You can put the plus c there if you really want. But the question we've been asking is, what if I didn't have that factor there that came from the chain rule by taking the derivative? So what is the integral of e to the x squared dx without the 2x? Do you have a guess about that? Same pattern we've been doing? Is that equal to, well, if I don't have that anymore, what I had happen in the others was I ended up with a 1 over that kind of factor, right? So seems like we're just following the pattern. Let's check it. By taking the derivative. And what happens if you try to take the derivative there? Well, you've got an x in the denominator and an x in this other term. So you end up needing either the product rule or the quotient rule, depending on how you want to see it. So I need the product rule or the quotient rule. And we'll give that an official yuck. We don't want to deal with that. Does it all work out? It turns out no, it doesn't. So it ends up not working out. Our guess was not right. Well, I'm glad we made a guess, because it would have been nice if it worked and we learned something knowing that now that we learned it doesn't work. So, what is there to do? Maybe we need a more systematic way to figure out when things are going to work. Like here, would you have guessed that this integral just gives e to the x squared? I probably wouldn't have when I was first learning calculus. And can we see that this maybe isn't going to work before we even try all that product rule stuff? So I'd say overall we want a systematic way to work on these things. And that systematic way is U substitution, not a big surprise. Someone once asked, is that integral equal to 1 over 2 log x times e to the x squared, figuring that something about the the 1 over 2x and integral of 1 over x is log and stuff, that also ends up not working. All right, so our next video will actually introduce how we do u substitution.